Okay guys, real quick, let's go back over wavelength, frequency, and energy. Okay, so we're going to start with wavelength. All right, this is our practice sheet that we did in class. We're just going to review a couple of them to make sure we're good. So when we get to our quiz and our tests, we have a solid foundation. Now remember, when you're doing wavelength, okay, our triangle is wavelength C and V. And remember, our C is our constant, okay? So this question asks for number one, what is the wavelength? So I know I'm solving for wavelength. So my equation is going to be wavelength equals C over V. Okay? Now, it gives me frequency, which is perfect because that's what I'm missing. So when I plug this stuff into my equation, I'm going to get my constant, which is 3.00 times 10 to the 8 meters per second over the frequency that's given, which is 3.76 times 10 to the 14th per second. Now, just a second, real quick, and in my class I talk about this a lot. This is a little confusing when you talk about frequency. The unit of measure for frequency is hertz, or it can be per second, or it can be second -1. I need you to understand that all of these things are referring to the same thing. So remember, frequency is the count, pretty much, like miles per hour. So this would be a number per second. So it's how many wave cycles we can get through in 1 second. So it'd be like a number per second. I generally rewrite all of mine to this per second because I like that better. I'm a little more used to seeing miles per hour, things like that. And a lot of times I find when we see a negative exponent, we're like, oh gosh, we just don't really know what to do. So when we look at this problem, we want to remember sig figs. Okay, so we have our given number. Oh gosh, sorry. Our given number is this 3.76 times 10 to the 14th. So we need to round to 3 significant figures in the end, okay? So my answer, once I plug this into the calculator, remember top down, you got to remember to put this bottom number in parentheses or it's going to all give you different numbers. So once I plug this in, I'm going to get 7.98 times 10 to the -7. Okay. Now, remember with your unit of measure, wavelength is always measured in meters. If you watch another video or as you progress to higher chemistries, we would end up going to a nanometer, which is when you look through the spectrometer is what the unit of measure was. But for our case, we're just getting to meter, and then later on you can progress to the other. So this would be my answer. All right. Now, let's do another practice problem. So let's do, okay, so let's do number 6. Now, number 6 is a little different because it gives you centimeters. So again, you're looking at meters, so you're looking at a wave. So this is wavelength. But the problem is we can't use centimeters. We want meters. So we're going to King Henry died unusually drinking chocolate milk. So we're going to start with centi and we're going to go to meters. So we're going to go 1, 2 to the left. So 2600 is going to go 1, 2 to the left. So it's the same thing as 26 meters. Okay, so let's take a second and let's work this out real quick. If you want to pause this and try to work it out again for yourself and then unpause it and see if you get the same thing, that would be an awesome way to practice. Okay, sometimes watching people do them isn't enough practice. You need to pause it, try it yourself, unpause it, and see if you get the same thing. Okay, so there's my wavelength, V and C. So this time on my problem, I'm solving for frequency. So V equals C over lambda, which is my wavelength. So again, my C is my constant, 3.00 times 10 to the 8th meters per second. Okay, and my wavelength is 26 meters. Okay, now when I plug this into the calculator, we are going to get a really, really, really long number, not in scientific notation. So let me show you what I got when I put it in the calculator. I got 11, 5, 3, 8, 0.5, 3, 8, 4, 6, 1. All right, so this is the number that I got. Okay, now please notice that out of the problem given, it was originally 2,600. Okay, so this number up here is going to be 2 sig figs. So my answer needs to be 2 sig figs. Now remember, when we're rounding for significant figures, you can drop everything else after the decimal place. Okay. I do find that oftentimes when it's a really big number, or when rounding gets a little, when sig figs gets a little scary, I find it beneficial to throw it into scientific notation. So we'll work through both ways. But if we want to hold 2 sig figs, this would be 1, this would be 2. So essentially we want to get rid of all of this stuff back here. Now remember, guys, if we just dropped this 5 and everything after, it would change the place value of my 1. So I can't just drop it. So instead of dropping it, I'm going to put my placeholders, and those are going to be zeros. Okay? Now we need to look back here at this last number we dropped. It is a 5. So since it is 5 or greater, we know that our 1 needs to bump up. So my answer is going to be 12, and then my 6 zeros. Now this is totally fine because I'm at my 2 sig figs. Now personally, I probably would have put this in scientific notation. So if I'm going to scientifically note this, my answer is going to be 1.2 times 10 to the 7. Now, remember, we were solving for frequency. So if we're solving for frequency, it's going to be per second, or it could be hertz, or it can be seconds -1. All of those are interchangeable, okay? So this would be my answer. All right, so guys, if you need any more help on this, please shoot me an email. As we look at the energy video, which will be the next one that we do, it will do a little bit more practice on if we were to put these two problems together. And that is definitely the more critical thinking version of this. So check out the other video if you need any help with that. All right, thanks guys.